Tables number 4 is from the 2017 exam. It is a calculator active question, and I am given a table of values that represent the area of a horizontal cross-section. This question will give us a nice review of that area volume unit that we just did. In part A, I'm asked to use a left Riemann sum in order to find the volume of the tank. So just keep in mind, one of the things we talked about in Unit 8 was to find the volume, you integrate the cross-sectional area. So to find the volume, I integrate that cross-sectional area, and it's in that integration that that left Riemann sum comes in, because a left Riemann sum is just the approximation of that integral. So up here, I just look at the difference of my interval. So from 0 to 2 is 2 units, and then pull the number on the left. So that is my 2 times 50.3. My next interval goes from 2 to 5, which is 3, times the height on the left is the 14.4. And my third interval from 5 to 10 is 5, times the height on the left is the 6.5. Multiplying and adding these numbers gives me 176.3. Even though you do have a calculator, you're still not required to do these calculations. That is still an optional move. What you earn point-wise is 1 point for a correct left Riemann sum. You earn a point for that final answer. If you don't write that final answer, if you were just to leave it like this, then you would earn 2 points. I'm also asked to indicate units of measure. And as you know, if you're asked to do that, there's a point tied into it. This is a volume, and I know volume is measured in cubic feet. You don't earn a point outright for saying cubic feet. You have to get some other units right in order to earn that point. So just put that point on hold for right now. In part B, I'm asked if my approximation in part A, if my 176.3, is an over or under estimate. So we just go back to a left Riemann sum and how you know if that over or under approximates a value. In the sum of the problem, I'm told that A is continuous and decreases. So I just drew a little decreasing portion of a graph. And if I do a left Riemann sum, that means the left corner is going to be touching the graph. So if I draw some left approximating rectangles here, I can see that I've got these little bits that are over the graph, so this is an overestimate. And what is causing that is the fact that my function A is decreasing. That explanation is worth 1 point. You want to make sure that, number one, you answer the question by saying over or under. Make sure you mention the graph. You don't want to say because it is decreasing. You have to mention the graph by name, and its name is A, and then just decreasing. You don't have to say anything more than that. In part C, I'm given a function f of h that represents the area of a horizontal cross-section. And again, we know in order to find the volume, we integrate that cross-sectional area. So I'm going to set up this integral, which is going to earn you 1 point to do. And since this is a calculator question, you're just going to type that into your calculator and come up with this answer, 101.325. Make sure you go 3 decimal places out. And that's going to earn you a 2nd point in part C. Again, I'm asked to indicate units of measure. This is a volume, and I know volume is measured in cubic feet. And just like in part A, that unit in and of itself isn't going to earn me the point. I'm going to have to get one more unit correct in part D in order to earn that unit's point. In part D, I have waters pumped into the tank. When the height of the water is 5 feet, I'm going to start writing my information here off to the side. So my height is 5 feet. The height is increasing at a rate of 0.26 foot per minute. So that would be dh dt. That's how you represent a rate of change, 0.26 feet per minute. And I'm asked to find the rate at which the volume is changing with respect to time. So I'm asked to find dv dt. My volume equation from part C is this one right here. But that was specifically for a height up to 10. I want this to represent any height, so I need to replace that upper limit. Instead of a 10, I'm just going to call it an h so it can represent any height. So because I'm using h there, when I go to write this function, I'm not going to call it f of h. I'm going to call it f of x. I just need to do a change of variable because h is taken up by that upper limit. Because I'm finding dv dt, I'm not going to do this derivative with respect to t. To do the derivative of an integral, I'm going to use fundamental theorem part 2, which says to do the derivative of the integral, I take my upper limit and I plug it into the function, so that's what the h is, times the derivative of the upper limit, that's the dh dt. That derivative, using the fundamental theorem part 2, is worth 2 points. And then at h equals 5, now I'm just going to substitute in my values that I have listed out. So at h equals 5, I'm going to replace the h with the 5. My dh dt I have over here is a 0.26. And then I just need to use my calculator to calculate f of 5 times 0.26, and that ends up being this 1.654. And one more units that I have to list here, indicate my units of measure. This is the rate of change of the volume over time. My unit should follow volume, which is cubic feet, over time unit, which is per minute. And if you get that third unit correct, along with the units in parts A and C, then you earn the units point, which is just a general overall point right here. You have to get all 3 right to earn that 1 point. If you miss even one of them, then the point is not earned.